Hello viewers, in today's session we are going to discuss an important problem from increasing functions. So here we have this problem where we have to prove that the function f of x which is equal to 3x minus sine x is an increasing function for all x belonging to the set of real numbers, right? So before solving this problem, let us first quickly see the definition of increasing function in terms of derivative. Suppose we have a function, say y is equal to f of x, which is defined in some domain D, right? And if the derivative of this function, that is f prime of x, is greater than 0 for all x belonging to the domain, then the function y is equal to f of x is said to be an increasing function. So here if the derivative, that is dy over dx, that is the slope, is always greater than 0, or this quantity is always a positive quantity for all x belonging to D, then the function y is equal to f of x is said to be an increasing function. So here will prove this function to be an increasing function using this definition, right? So let us here find out the derivative of f of x, right? So f prime of x is given by d by dx of 3x, and then we have d by dx of sine x. Now f prime of x is equal to 3 times 1, because we can take this 3 outside this derivative operator, and the derivative of x with respect to x is 1, and the derivative of sine x is cosine x, right? So f prime of x is now equal to 3 minus cosine x. So now we have to show that this derivative is always a positive quantity for all x belonging to R. So for this we have to take help from trigonometry. So here we have cosine x, and we know that the range of cosine function is given by this interval, that is minus 1 to 1. So we can now here write cosine x greater than or equal to minus 1 but less than or equal to 1. And remember here the domain of this function is the set of all real numbers, right? So let us start with this inequality. So here we have negative cosine x. So let us multiply this inequality throughout by minus 1. So here we have plus 1, here we have minus cosine x, and here we have minus 1, and the direction of the inequality gets reversed, right? So we can also write this inequality as minus 1, and then we have minus cosine x, and then we have here plus 1, right? Okay, so here we have 3 minus cos x. So let us add 3 throughout this inequality. So we have minus 1 plus 3, then here we have 3 minus cosine x, and here we have 1 plus 3. So 3 minus 1 is 2, and 3 minus cos x is given by the derivative, that is f prime of x, and here 3 plus 1 is 4. So from this inequality we can easily conclude that the derivative it lies in the interval, that is 2 comma 4 for all x belonging to the set of real numbers. So now from this interval, we can easily conclude that the derivative f prime of x belongs to this interval, and here 2 is a positive quantity and 4 is also a positive quantity, right? So f prime of x is always going to be a positive quantity for all x belonging to R, because here 2 is positive and 4 is also positive, and the derivative is having values between these two numbers, including 2 and 4, right? So f prime of x is always a positive quantity for all x belonging to R, and from this definition now we can easily claim that the function f of x is an increasing function, because the derivative is always a positive quantity as f prime of x belongs to this interval. So f of x is an increasing function for all x belonging to R.